Hope everyone has got it down, but I'm going to remove it in a minute. So what I will do now is, before starting another lecture or presentation, I will go through some of the basic aspects of what we mean by integrated water management, starting from very basic, so that whatsoever I covered in the first lecture, I think that will give a little bit more understanding for those who are not from this area, and this may be something new for them, and it will help them to understand the future presentations, lectures too. So we use the word so under the integrated water management, what we are considering that all the resources are useful. That means the freshwater resources is one, and wastewater and stormwater. Earlier we used to consider them as a waste, and they were discharging into the receiving environment. Wastewater, we were treating it and then discharging it to the extent that permissible by the regulatory authority. So regulatory authority can be the environmental protection agencies, Central Pollution Control Board, or state, they have their own agency. So we are considering them as a waste and discharging into the receiving environment to a certainty. The stormwater was never treated, it was discharged without treatment normally. But now some states, somewhere they have limitations that the discharge should not have nitrogen, phosphorus, suspended solids up to a certain limit. They can discharge once it is treated to a certain limit. And water sensitive urban design is playing a role in the treatment process. So that means if you're looking at the integrated water management, we are considering not only the fresh water, but also the wastewater, the stormwater, and then also the rainwater. The rainwater is basically that is being collected from the roof. Say for example, we have a house. So what's what water is being collected? Maybe we have a rainwater tank. And then it is used for internal supply. So the rainwater is one source, because until as it is hitting the ground, it is rainwater. Once it is hitting the ground, we call it stormwater. So that is the differentiation we normally consider in rainwater and stormwater. So we try to collect, because the quality of the water can be much, much better of rainwater than the stormwater, because we are directly collecting, depending upon what the type of the roof is. One, that's the important aspect which is playing. Then the wastewater we can divide into two parts again. So one, the flow which is coming from bath, laundry, we call it grey water. And the toilet supply is basically, we call it black water. In further, what has been done, they are developing a different type of cistern seeds where they are separating urine again, and they are using that, collecting in a small container, and they are using for fertilizer. So further it has been, but it has not been much successful. because the collection issues and management issues, but the trial has been made, and in some part it is still being used. So that means we can divide that wastewater into again two, and in some houses they are putting separate collection system, the plumbing system for grey water and separate for black water, which is directly connected to the sewer network. And the overflow from the grey water, which goes again to sewer network. That untreated grey water is also being used in some of the areas in garden, directly providing water to the plants. So that means we can divide even the grey water into two components, black water and grey water. And then we can have different applications. Basically, the idea is that how much pressure we can reduce on the freshwater sources because they are in limitation. And the another advantage is that if you are using alternative resources, that means we are using them locally where it is being generated. That means the treatment disposal is local and supply is also local. So you don't need a very large network for that. So in that way, what we are doing is basically if we are providing the water for drinking and bathing and laundry through the freshwater sources, which we call piped water supply, and for other purposes like, for example, garden watering, toilet flushing, car washing through the another source, that means we are reducing the overall load on the freshwater resources. So in the case of integrated water management, we are considering all the resources which are available and then how best we can utilize them based on fit for purpose. That is the concept which you have to keep in mind, fit for purpose. The quality, based on the quality, where it can be utilized. So this is a basic aspect of it. So what we can do is, if we are providing, so we can develop options for providing water supply for a smaller development or a large development. We can say, look, initially we are planning, one option is that we provide water supply for all the applications or the uses from the private water supply system. The wastewater which is generated is treated and disposed of in the receiving environment. And similarly, the stormwater is collected and disposed of into the receiving environment. That's the one basic option. The second option can be that, okay, we will collect the rainwater. We will provide rainwater tank in each and every house. And then we will provide that water which is collected from the rainwater tank for toilet flushing, garden watering, or car washing. But depending upon the area where we are providing those rainwater tanks, the water may not be available all the year, every day, because it is depending on rainfall. Where the rainfall is quite uniform, there is more water which is available within the smaller capacity of the tank. So the sizing of the tank is very important aspect in case of when we are providing water supply using rainwater. The sizing of the rainwater tank, that will depend upon the connected roof area, how much water is being used, what is the rainfall pattern, and as we increase the size of the tank, we are providing more cost to it. So there are one software which we will be providing to you. You can run it on your computer, and we will see whether we can run a smaller exercise for its application. So we call it volumetric reliability in the sense that how much water is available from the rainwater tank. Otherwise, what will happen is there will be overflow, and that will be going to the stormwater network. Then what we can do is, at a cluster scale, we can collect all that wastewater which is coming from the houses. We can locally treat it to a required standard, and supplying back to the houses through a dual pipe system. So there is a one pipeline on this street which is for potable supply. There is another pipeline on this street which is providing recycled water. And that recycled water which is going to the homes basically will be supplying water to the garden and also sometimes for car washing. Okay. So that means we have another infrastructure, but the advantage is that we are reducing load on the freshwater sources. The third application can be that we can collect the stormwater and store it, treat it, and supplying back to houses through a dual water supply system. So under the integrated water management concept, we are looking different options for providing water supply for residential. And also we can have similar options for industrial where that water can be utilized depending upon the type of industry, depending upon type of application of the water over there in the industry. And similarly, we can think of providing or integrated water management system for commercial, where multi-story shopping complexes. There are a number of toilets there. The supply can come through alternative water supply sources. They can have their own larger rainwater tank system. So this is the basic concept which talks about integrated water management. Any questions?
How do we define stormwater?
How we define stormwater? So, as I said before, the water which we collect from the roof before it hits the ground, it is rainwater. And then when it hits the ground, it is stormwater, runoff.
So when we are talking about management of stormwater, we are talking about the rainwater that has been drained out from the roads or urban areas.
So if you are not collecting from the roof directly, then it will convert into stormwater.
So for how many number of days or months can we use it for any application? It is a very limited number of days in which we will get stormwater.
Yeah, that's a very good question. So that's where what we can see that, okay, from start day one, we are looking for a year, for example. Day one, there is no rain, there is no rain. Day two, there is a rain for so many millimeters. How much water will that generate based on the roof area? And then how many residents are living in that house? How many times they're using water in the toilet? Okay. So if you see that, and then the collection of the rainwater in a tank. So all those aspects, we can develop an Excel sheet. There are programs available that can give you, okay, in the year, based on the rainfall pattern, only 300 days the water is available from the rainwater. Okay. For remaining 52 days, 360 out of 365, remaining 65 days, we have to have the water which has to come from potable supply. So normally what happens is that when we have the rainwater tank, so there is a connection from the potable supply. Okay, that will start working only when there is no water in the tank. So otherwise, it is coming from the roof. The water is going to the houses. But if there is water level below a certain depth in the rainwater tank, then the water will be coming from the potable supply source. Okay? And then in that case, we have a mechanism where the water level will be dropped up to a certain depth. Otherwise, if you fill it up and there is a rainfall, then there is no capacity in the tank to water. So these are some of the concepts we will be talking about in lecture on wastewater. But this is how it works. In Australia, they have developed a talking tank.
There must be indicators.
Sorry, there may be.
Indicators must be there.
Yes, there is a mechanism. They have developed a talking tank. The talking tank is that the rainwater tank is connected to the Bureau of Meteorology. Okay, Bureau data. Okay, there will be a rainfall in coming 4 hours or 6 hours or tomorrow. Then there will be a signal to the sensors in the tank that okay, the tank will discharge the water into the stormwater system. Okay, it will empty before the rainfall. So the advantage is that whatsoever the rainfall is, we are capturing the stormwater. Okay, so it will reduce the pressure on the stormwater network. So that is the concept that has been developed. It has been implemented. It is all working on a small database computer system network, which is being operated centrally and providing signals to the rainwater tanks. So there is a lot of work going on in that area. So basically the idea is that we are discharging certain amount of water which is already there in the rainwater tank before rainfall. That means we are utilizing the capacity of the stormwater network and not increasing the pressure, means the flow. The peak flow will be reduced significantly that way. Okay. So there is no overflow from the stormwater network. So these are some of the concepts which are being utilized.
What about sediment load?
In the sediment load in the rainwater tanks, they normally, depending upon in which area that particular rainwater tank is, somewhere the load will be a little bit more than the others, but they clean it regularly, maybe after 6 months or a year or 2 years time, they remove the sedimentation. If it is not being utilized for drinking purposes, then it can be a little bit longer. But there is certainly some sludge which is being deposited in the another way they also do it, they have a first flush system. So basically what will happen is the initially few millimeter of rainfall, rather than going directly into the tank, it will be going into a smaller chamber, and then it will be discharged into the ground. There is a very tiny hole that will take into consideration the initial, which has more concentrated particles, and that way it will be removed, not going into the tank. So there are certain mechanisms which are being utilized. So there is a book which you will be getting a copy of it. I think we will provide a copy of this book, which is published by International Water Association. We will be covering tomorrow. Dr. Sharma will be talking about it. So it talks about every aspect, even looking the community consultation, even looking different aspect, modeling, maintenance, operation, every aspect. So this is all about a basic idea about integrated water management. But there are other aspects which we have to cover. One is looking the community consultation.
Sorry to interrupt you.
No, that's all right.
Filters also. The outlet.
Yes. So
Filtering or small trucks, which option is better?
uh,
Special trucks or filtering?
filtering will remove only the coarse particles. Yeah. But this first flush system can also remove the fine particles too. That's the advantage. But many places you will see both because mainly the leaf, if you are living in an area where there are so many plants or trees, I think there is a lot of leaves that are coming on, and they collect on the gutters, and then slowly they start coming into the pipe. So I think most of the houses are using both type of systems here. There is another aspect which we have to consider is when we are looking those type of systems, any integrated water management, the economics aspect of it, the environmental aspect of it. Basically, because we are providing a dual water supply system, and the cost to the community, the householder will be more. In that case, the cost is transferred from the public utility or the government to the householder. So we will be talking about those a little bit more in detail. Ultimately, the energy consumption is another important aspect. Greenhouse gas emissions is another aspect when you are comparing different options. So there are frameworks or methodologies, methods for assessing different options for providing services, whether you should have stormwater or wastewater treatment and reuse and recycling. So different options have different cost considerations. They have community acceptance is also great, very important. So far, public is not very much interested in any part of the world for indirect potable supply. Means there are two ways of providing wastewater. One is that you treat the wastewater to a high standard and then you dump it to the reservoir. So that is the indirect potable application. In some way, they also try to directly treating to a very high quality and then injecting into the network system. The community is not very much interested in that type of systems because still there is a yuck factor about the usage of treated highly treated wastewater. Okay. So these are some of the aspects which we have to consider while thinking about. So coming back to the community consultation, which is not that much in our Indian context. We are not going to the community and talking to them what type of system they will prefer or what is their liking, how much money they are ready to pay for. Because providing sophisticated water supply system, even that needs a lot of money for operation and maintenance. Who is going to provide that money? Whether the state is happy to provide or the user has to pay. The user payment, system has to be sustainable in a long term. And for operation and maintenance, if you are running the system, the money has to come for, which can be the chemicals, which can be the electricity supply, which can be the parts and labor, which can be the operator's cost, and also the pipe network maintenance. So everything is counted and recorded. So asset management is another very large, important area for any integrated water management system. Okay, so this is something basic aspect which I want to cover before going to the next presentation, which is more about the framework. So the framework for assessing or for planning purposes for integrated water management or water sustainability design. So there is one manual which you can see on the on the presentation. This was written by us for basically the American Water Research Foundation. So most of my presentation is coming from this book. A copy of this book will be provided to you in the resources. So it can help you to understand about the planning process. It is not about the designing. It is about finalizing the concepts, finalizing the options, and working with the community, the stakeholders. The stakeholders' involvement is very, very important. I think what you're talking about in the morning, that stakeholders, there are multiple stakeholders. They don't talk to each other. And that's why the systems which we develop may not work because of that aspect of not communicating, not agreeing to one solution, not cooperating. So these are some of the challenges. And this documentation talks a lot about stakeholders' engagement, option assessment. I think there was some discussion about the technical aspect too. That is another area. Once you have finalized, these are the options which you are going to consider, then how technically we can provide that solution is another aspect. So these two factors of the consideration should go side by side. One, we decide through the consultation process, the looking how much money we have, the resources, and then we look for the technical aspect. So sometimes we go side by side because for the consideration of the economics aspect, we should also know how much will the cost involved in providing a particular solution or particular option for water supply system. In that case, we don't go for a detailed design. We normally go for conceptual design. Conceptual design will provide the sizing of the system, but not in detailed design. The detailed design, we go only once we have decided, okay, this is the option of the system we are going to provide, then we go for a detailed design. So basically what I will be covering is the assessment of different options, conducting conceptual design, conducting life cycle costing, looking the energy aspect of it, greenhouse gas emissions. I think I will give you one example, not today, maybe next presentation about a case study, actual case study which we covered for an area of 3,000 hectare area with 80,000 population. We looked different type of approaches in integrated water management, and we looked the conceptual design of infrastructure options, used EcoCycle, the software which we will be providing to you, and then finally we decided, okay, what system will be more suitable for that community. So basically the idea is that by doing all this analysis, we are providing information to the decision maker. It can be the government, it can be any agency who is funding, providing information with more information so that they can make the informed decision. So basically it is about making the informed decision about looking all aspects. Okay. So with that, I will start another presentation, which will be covering more about the framework. Okay.
Visible?
Like
Presentation be blocked.
I think we can keep it over here. You haven't seen the presentation?
Visible? Okay.
I think there seems to be some imbalance. I think those sitting on that side can occupy some spaces over here. When you go in a plane, I think they try to steer so that the plane is not imbalanced here. Okay. So this presentation is about the frameworks, means how are you going to plan for integrated water management options and what are the activities that are involved. As I said before, most of the part which I covered in coming from this document, which you will have a copy, and I think it will be good if you have a read, because I will not be covering every aspect of this overall. So what I'm going to cover is basically integrated water management, planning, water system and design, drivers, objectives, because when you are looking for any framework, under that we should have very clear cut idea what are our objectives for providing those services. These type of approaches are very much specific to local conditions. That will involve the topography, that will involve the other aspect of conditions, how much users can pay, what are the local guidelines for providing those services, because each and every state normally they have their own guidelines, what type of water quality, how much water supply per person should be supplied for greater water supply. So these are some of the aspects which we have to look into before thinking about planning for any water supply system under integrated water management approaches. And the another thing which we have to be very careful about, or we have to consider, if there is an existing system in that area, what is the capacity of the existing system? What has to be improved? Whether it has to be duplication, whether we have to provide a new water treatment plant or new wastewater treatment plant, whether there is only the additional capacity because of the increase in population is needed. So these are many aspects that has to be looked into, and some of those aspects which you will find a little bit more detail in that documentation which I'm talking about. So integrated water management, basically, the definition of this, I think we talked about few definitions before, and this is another definition, offers a set of principles that underpin better coordinated, responsive, and sustainable resource management practice. It is an approach that integrates water resources, water use actors, water services, and water management skills. Basically covering all aspects of water management. It includes those who are operating, the local guidelines, the management. Every stakeholder will also be involved in it. So the integrated water management recognizes the alternative water resources, differentiate the quantities and potential of the water resources, views water storage, distribution, treatment, recycling, and disposal as part of the same resource management cycle. So we are looking at the overall integrated water management. Okay, so not only water supply, we are looking at the wastewater, we are looking at the stormwater overall, and that also covers the rainwater, stormwater harvesting, every aspect that is covered. Seeks to protect, conserve, and exploit water at its source. That means, for an example, water coming from the roof, we are trying to utilize at that particular point only, at household scale. So use it from where it is being generated. It may not be possible in all the cases, but this is one aspect that we have to consider. Whether we can do it, that means the idea should be there, okay, which are the resources that can be utilized where they are being generated. So the advantage is that the network that you need to transport, once we are collecting it for the treatment and then supplying it back to the houses. So we need collection and disposal, the collection and distribution network. Whether we can minimize that network, that is one aspect that we have to look into. Account for non-urban uses means wherever the water is being utilized, take into consideration in your planning all those non-urban uses. That is the agriculture. So if you are collecting water from a river, and that river is also supplying water for agriculture applications in nearby areas, so we will not forget about those. We will just not consider the urban water system. It has to be done integrated way. So you consider all those who are using water from that particular catchment. Align formal institutions, organizations, legislation, and policies and informal practice norms and conventions that govern water in and out for city. So basically, everything has to be looked into, legislation, all the stakeholders, and also all the existing users. So in the planning framework which we are looking for, everything should be included and considered. Recognizes the relationship among the water resources, land use, and energy. So the system which we are considering, if it is utilizing a lot of energy, we have a lot of pumping systems, the treatment, the energy usage is very high, but we are developing a lot of greenhouse gas emissions. That is again not good for the environment. Okay, that aspect has to be considered. Some of the water utilities now is thinking about zero net energy applications. Okay, so they want to generate their own energy and to be on the natural, whether using sunlight or solar and all those things, or sometimes they are generating their own energy from the waste treatment plant. So net zero energy is a new concept which is being utilized now. Simultaneously, because economic efficiency, social equality, and environmental sustainability. So social equality is basically providing services to everyone. So not differentiating between different regions, different groups, and encourages participation by all stakeholders. And this is one of the most difficult aspects of bringing all the parties together for any planning purposes. So the drivers for integrated water management, as I think we discussed briefly during our first presentation too, there is a rising demand because of the urbanization, diminishing surface and groundwater resources, which is happening because of the climate change. Climate change is another important factor. Degrading environment, stormwater and wastewater discharge, because there is an increase in stormwater and wastewater discharge into the receiving environment. And that means it is impacting on the quality and the of the water which is flowing into natural environment. Stringent regulations for wastewater and stormwater disposal and aging infrastructure. These are some of the factors which are driving for developing or using integrated water management. And then that's why we need some frameworks for how best we can plan for using integrated water management approach. So benefits basically are providing water security, means providing water services to the community, because if you are relying on conventional approaches, then there is a greater load on freshwater resources. By using this approach, we are using other resources and producing less load on the freshwater. That means, based on the fit for purpose concept, we are providing water more security to the water supply system. Reducing impact on the environment, because we are discharging less stormwater, discharging less wastewater, or we are treating stormwater before it is discharged into the receiving environment by using water self-chairman design approaches. Improving system-wide, the performance of the system means those systems can supply the water for a longer term and with a better quality. Improving coordination, collaboration, and participation of the service management means those who are providing those services, we can have better coordination management. That is one aspect of that should be considered into integrated water management framework. So this is the diagram which you are looking over here. This is the planning process, and this is one type of framework which we can say it's not only the framework. There can be a number of frameworks for developing integrated water management systems. But this is one which was developed for this documentation, for this report, which I'm covering over here, but I will be covering a few more. This is more about the planning framework, but there are others where we can assess different options for their suitability based on economics, based on the environmental factors, based on the social consideration, based on the technical aspect. So I will be covering a few more in other lectures, but this is what I'm going to cover today, which has been worldwide acknowledged, which is presented over here. So if you look over here, activity 1, if you are looking for an area for developing integrated water management framework of the approach, so first of all, what we are doing is talking to the stakeholders. And then what we are doing is agreeing on the objectives, measures, and criteria. The third aspect is understanding the current system, whether we have is already water, wastewater, stormwater system over there. I will be going a little bit more quite in detail about each and every aspect, but this is one diagram which is overall picture of the whole process. The fourth is assess system performance. So once we have decided that these are these approaches or type of system we are going to provide, then we are considering through different tools, which can be the modeling tools, which can be the assessment tools, with performance, how that system is going to perform. That next activity will be looking at the performance of those systems. And the last one will be the implementation aspect, is then going for the detailed design. Okay. But this also is covered into 3 phases, and I will just talk about a little bit more about those systems in a few slides. So this is what the overall very simple diagram showing that, okay, for this particular region of the area, we have developed an integrated water management system or approaches we want to utilize. What you're going to do is talk to the stakeholders, organize meetings, agree on objectives. What is the objective of providing services for that area? And then what will be the measures and then how we are going to assess, under what criteria we are going to assess those. And the next one will be understanding the current system. If there is a current system, what is the capacity of the current system? Whether we can utilize that system, where we have to upgrade that system. So basically looking the whole aspect of the existing system, investigation of the existing system, understand its capacity, and then assess the overall performance of the options which we are considering. And the last one will be looking how we are going to implement it. So a little bit more description on those activities which we talked about. When we say having a conversation among the stakeholders, conveying a key stakeholder group, bringing them together, a representative from different organizations, which will be the part of the overall planning process. Those who will be involved, they will be having benefit of, or any regulatory aspect of it, they will be looking for. And even the community, which will be community representatives, they all should be coming together to understand the planning process, how we are going to plan the integrated water management system for their community, for that particular reason. So bringing everyone together, they will be looking basically, the consultation will be all essential aspect of that process. They will provide, okay, this particular system is suitable or not, whether they agree for it, there will be some issues with that system. So everything has to be considered by that committee, and then those technically working on, they will be providing information to that group. Okay, you discussed about these 5 options. This is the cost, this is the environmental impact, how much the pollutant we are discharging into the receiving environment. So all that information will be provided to that group. The second part is that group which we are talking about, the stakeholders group, they should agree on what is the objectives of providing those services. Then how we are going to measure our objectives, and the criteria and the methods. The assessing the method, how we are going to finally say, okay, we are achieving the objectives. What are the criteria for those? For example, we can say for the receiving environment, there should not be so many kilograms, more than so many kilograms of nitrogen or phosphorus. So many kilograms of, so many tons of total suspended solid. So there should be some criteria, numbers. In some, there can be the exact numbers, mathematical numbers. In some, they can be, community can say, oh, this is looking better. There can be 2 types of criteria. There can be qualitative and quantitative. So agreement on integrated water management objectives, their qualitative and quantitative measures, analysis methods. The third one is the understanding the current system. Understand all aspects of the current system, identify potential strategies, develop viable alternative configurations. So once we have seen, we have understood the existing system, then what we have to do is, okay, this is how much we can utilize the system, but we need additional data system to provide services to meet our objectives. So we will be talking a little bit more using some of the examples of some of the development which we have done. We have developed solutions of the proposals in our next presentation. Then assess them performance and select system portfolio. So the system portfolio is maybe, okay, in one option we are using rainwater tanks, we are providing rainwater tank supply to toilet supply for garden watering. In another case, we are using stormwater system. In the third portfolio, we can have the portfolio supply. And basically the aim is how best we can minimize the freshwater resource. So that is the end, and that will depend upon local conditions, how much resources are available in that area, and what type of resources are available. So everything has to be considered in discussing or planning these portfolios, developing those portfolios. Portfolio is nothing but options of providing services. Along with the existing system, assist decision makers. Basically, this will assist the decision makers in selecting the best option. Once we have developed the portfolios, we will analyze all the portfolios based on what infrastructure is needed and what is the cost constraints, what is the cost associated, how much will be the impact on the environment, means it can be the greenhouse gas emissions, it can be the impact on the receiving environment, how much discharge of pollutant loads to the receiving environment. So all that aspect has to be considered. And sometimes the infrastructure itself has a lot of embedded energy. Means starting, say for example, if you're providing a water supply network to an area of maybe 10 square kilometers, we are using a large amount of water, pipe network. That pipe network is being manufactured starting from the material which are bringing from the mines to the manufacturing of the pipe, the laying of the pipe. Every stage that involves energy application. Up to the final, when it is constructed, when it is implemented or laid in the ground, how much energy has been used up to that end, that is part of the greenhouse gas emission. So we start collecting all that data. Say for example, I have 100 kilometers of pipe that has to be used in an area. So how much the total energy has been used in up to the laying of those pipes, and that will have one is the embedded energy, is basically the energy in developing that pipe, constructing that pipe and laying that pipe. That is the embedded energy. And the second part of the energy in the system is the energy, actual energy used in pumping into the system, in the treatment part. So that is one energy. The second energy is the embedded part in developing that infrastructure. So when we're looking the overall environmental impact, we are considering not only the energy that is required in providing services, running the motors, running the pumping plants, running the boosters, but also the energy required in laying, manufacturing those pipe network systems. So it is only the pipe, not only the pipe network, it can be the motors, it can be the parts of the treatment plant. So every aspect has to be covered. So there are certain softwares available. Those can give us information about those types of embedded energy in manufacturing. So Sigma Pro is one. I think that is will be providing a little bit more information in one of the lectures. I'm giving one example of how we have calculated that energy. So the fifth activity is implementation.
Sir, in the fourth one, do you optimize also?
Sorry?
Optimization.
So the optimization is, so we normally do optimization of the network is one aspect, okay? So, but you can optimize one type of system which will have different cost.
Some kind of trade-off.
Trade-off. So we are looking the trade-off
Trade-off.
between, but finally what we are looking is the overall cost of overall infrastructure which has to be provided. So the trade-off has to be seen into the energy cost and the infrastructure cost. So there are a number of parameters where the trade-off has to be looked into.
So that is also incorporated in activity.
Yes, yes.
Some kind of environmental audit, we can say.
Auditing, or you can say, so the cost to the environment, how we can convert that into the rupees or dollars. So basically what we can do is, okay, we are discharging, say, for X kilogram of phosphorus nitrogen into the environment. Okay, how much will be the cost to reduce that to zero? So what infrastructure is needed? Okay, we need such a large bioretention system which will cost that much. So what is happening is some of the utilities or the water service providers, when there is a developer coming to them for starting a new development for 500 or 600 houses, they will ask, okay, can you show us what will be the amount of nitrogen, phosphorus, that's suspended solid? They are considering only three parameters in case of stormwater. You will be discharging to the receiving environment. And then they will say, okay, for mitigating that impact, we have to provide that infrastructure that can be a bioretention system or the treatment process. And then they will say, look, this is the penalty or the cost that you have to put in for mitigating that aspect. So in that way, we can convert that mitigation cost into dollar form. Okay. So there are different ways. So different utilities, they have developed their own approach of charging developers for mitigating that impact because of the development. So all that aspect that has to be considered into while we are looking different options, comparing different options. You also see in one option, this is the amount of suspended solids, nitrogen, phosphorus that will be discharged into the environment. And in one, it will be much more, it will be less. So our option will be looking the overall optimization, the trade-off. I think when we talk about one of the examples, it will be a little bit more clearer. I will give you some numbers and we'll talk about those. So there were three phases also in that initial diagram which we looked. So in those three phases, these activities are being repeated. You can see the phase 1, which is a smaller, then there is a phase 2, and the last one is the phase 3, which is, so in these activities which are taking place, it is taking place in the 3 phases. So what is happening is, in those 3 phases, so the first phase, what we are going to do is strategic decisions for urban water management, i.e. indirect potable applications and new groundwater resources applications. So basically what we are going to decide, what type of water resources we are going to use in first phase, the basic thinking. That information is transferred to the second phase, to the same group that is working on in their planning process. Output, short list of portfolios. Portfolios means the options for providing services at the household scale. Set of urban water management options. Options are whether we are going to use rainwater, grey water, stormwater, recycled water, dual water supply system, how much we are going to use portable supply. So all those for drinking purposes, and the toilet, the washing machine, bathing, showers, garden watering, all those identify where, what type of water supply will be more suitable based on fit for purpose, and that will give you the options. Okay. And the third phase, I think this will be refined, and that information go into the final phases for consideration by the stakeholder group. So, in the first activity which we talked about is the stakeholders. Who are the stakeholders? Community involved, users, specialized interest groups, and that is also because they will be finally the users of the system. Okay. Unfortunately, in most of the cases, we neglect them. The community is there once the development already been occurred, and those who are buying houses or apartments, they don't know much about what type of systems, the services they're going to get. And this is a very common issue because they are not the part of that planning process. In some cases, it is difficult if you are putting a new residential development, but if you are thinking of providing integrated water management options or upgrading the system in the existing area because issues like increase in density, then they should be consulted very actively. So the other stakeholders are water utilities means over here, I think it is the local municipalities to manage and operate. But in some part, there are different water boards. Even in India, we have some water boards in some states, those who are providing, managing, operating services up to the providing service to the householder. Regulators means the regulatory agencies. It can be EPA, it can be any other, those who are regulating those services. Or approval authorities, who is going to approve the planning process? Industry, it can be manufacturers, it can be whether we are proposing some system, whether they are available in the market, who is going to manufacture. So industry should also be consulted in providing service. The planners can be town planners. As you said before, the water system design includes the planning should include the water management. The planner should also be the integral part of the integrated water management or water system and design approaches implementation. They can be urban planners. They can be the transport planners. Any planning involvement should also be considered. Funding agencies. Who is going to provide the funding for providing those services? Whether it can be the third party, it can be the state government, or it can be we are approaching the World Bank or some other agencies, depending upon the size of the development, depending upon the cost associated with that, maybe the banks, where they are some money in providing services. And also this user group will also be discussing about how much they are happy to pay for those services. If we say, okay, we will be providing water at a rate of 10 rupees per kiloliter or something, which is much more than what other states or other municipalities are providing, it may not be happy. You have to convince them that if we are charging much more for water, this is the advantage, quality, or the supply can be 24 hours rather than having just intermediate supply. So these are some of the stakeholders, and the list can be a little bit longer depending upon who else will be involved in that area. Any suggestions on stakeholders?
Who come under special interest groups?
Interest group, it can be like, for example, residential welfare associations, agencies like that. They can come under that category. Any other question? So the second part is basically looking at the planning objectives. The setting objectives should include whether, for example, if you resource recovery. Resource recovery is basically from the wastewater treatment where we can have nitrogen and phosphorus we can recover from wastewater. Or waste recovery can be whether we can utilize that wastewater for supplying through the dual water supply system. That can be the resource recovery, that can be one, whether we are considering that aspect. Then we are looking the sensitivity of the environment, where we are going to discharge, how sensitive that environment is, what type of wastewater or this stormwater we can discharge, what treatment is required for the discharge, level of service required by the community, whether the community is happy by intimate supply, or they need regular supply 24 hours pressure in the system, or they are happy for having a dual water supply system, one for the potable and one for the non-potable. So all that aspect has to be considered, and then looking at the economic impact on the business activities, how much will the cost involved. So everything is taken.
Agency, private company,
Sorry?
like private company enterprises.
For conducting these analysis, or
Yes.
so there are so many consultants available nowadays. They can have
International.
national, international, both, depending upon the size of the planning process. So you won't be inviting someone from US or outside if you're looking for a smaller city or a state. But if you're looking these type of planning for the state, maybe that you will like to invite international consultants who have much more experience in that area. And I know that when it can be the government body too, some government agencies, they have that capability too. Yeah. So for example, in transport, they have so many territories there. Leather industry.
Yeah.
Okay. So
Textile.
I don't know about the textile, but yes, they have. But they hired someone from Australia to come and provide them solutions because they were discharging. I think they are pumping that waste into the ground. So there was so many issues with the groundwater. And they suggested some approaches, having decentralized treatment for few tanneries altogether, and then dividing them into group, and then how the waste after treatment can be discharged into, and where it can be discharged and whether it can be utilized. So some of the international experts can also be involved. But this area is developing a lot. So I think there should be a lot of capabilities even in India for providing support, providing guidance in developing those methods and options and assessing those options. I think this book can help a lot. And then I will be providing a few publications and reports which will help further in developing capability within yourself. So under this, basically looking the impact on city planning. So when we are developing the integrated water management approaches, we have to look all those aspects, and then based on that, we will set our objectives. Looking the sensitivity of the surrounding environment, energy uses, greenhouse gas emissions. So all those aspects should be considered in setting the objectives. And basically the idea will be, finally we will be going through the multi-criteria assessment in selecting the best option. So under the activity objective, then there are three main domains: social, environmental, and economic. And under those, we can have different measurements or criteria. Okay. I think there is a next figure that will give you some idea about what we mean by measures. When we talk about this integrated water management, what we're looking is the area which is sustainable. And that sustainable is basically uh, the, the area which is overlapping in the environmental, economic, and social aspect. And the technical aspect is also one of the most important because this will cover the environmental and economic aspect too, which is behind the scene. We are looking at the technical aspect because if you are looking some options, how we are going to provide those options, and which is the technical part of it, the design aspect of it, the type of systems which we need, the technology we need, and that is very important. What is behind the scene under these two dimensions, which is environmental and economic. So when we are looking those three aspects, how we compare the cost. Normally it is either the net present value. I think in your undergraduate studies you might have gone through this term. There are a number of equations available to get those values, considering the rate of interest, the inflation, and then you can calculate the net present value based on how long your analysis period is. Whether it is 10 years, 20 years, the lifespan of the services which we are going to provide. After 30, 40 years of analysis, it doesn't matter much because those inflations, the equation, if you look into the equation, number of years after 2025, the value change is very small. The annualized value of capital, operating maintenance cost, replacement cost of infrastructure, cost and benefit of to the community, externalities. It is very difficult to include externalities into the equation. Say for example, by providing water sustainable design, and we have developed a very good part for garden, and we are providing water supply for irrigation either through dual water supply system using alternative water sources, and that is very much improving the well-being of the community which is there living in that area. They go to the park in the evening, they enjoy, and so basically it is good for them for the well-being, providing a good social interaction space. For that, putting any dollar value or the rupee value is very, very difficult. And how the social scientists try to put those values is basically talking to the community and asking them, okay, if you have to pay, say for example, 100 rupees additional tax, will you be happy for it? Someone will say, oh, I'm happy to pay even 200 rupees per month. Someone will say, I'm happy to pay only 50 rupees based on their own thinking. So they try to analyze and say, then they can say, the cost associated which can benefit to the community is that much, based on how many are using that park, how many are happy to pay, and what amount of money they are happy to pay for keeping the garden green, the public open space green. So that is the externality part which can or can't be taken into consideration, but sometimes you can see that two options are equally good, but one option is more providing well-being to the communities, and then we can say, okay, there is some externality associated with that. Maybe we will prefer that option. So there can be so many examples for those externalities. Like for example, we are discharging less pollutants or the from stormwater sources. That is improving the water quality of the receiving environment. Flora and fauna can be, and it can be like for example, Ganga cleaning. How much money state federal has put into that? Leave aside the religious value of Ganges. There is the externalities associated with that. We feel good looking the water quality improved. How we are going to cost it? Maybe we can say, look, that is the amount of money which we have invested for making the Ganga clean to be. So the same thing can apply for any stream which is going through next to your development. Okay, so that is another important aspect to consider in your overall plan process. Regional and economic growth, return on investment. So basically, if we have good water supply system, good wastewater, stormwater system for a town, maybe the town will start growing. People can migrate to that area. Okay, that particular area has good 24 hours water supply system. The wastewater system is also very good. There is no flooding in that area. There can be some migration to that area. That area can start growing. There will be more industrial development in that area. So that can also happen. That can have impact on the regional and economic development. And that can indirectly the return to the investment. So that's more economic, core economic aspect, which we engineers sometimes don't understand that much. We are mostly involved with the costing and looking the cost aspect simply, not looking into much detail about the externalities, not looking the return of the investment and all those aspects. Okay, any question on that aspect? Feel free to communicate, because that should be two-way communication rather than one-way. Madam, do you have any comment?
It's difficult because there are activities involved in
Everywhere. Basically, the idea is by using those approaches to reduce the subjectivity. That's only, there will be certainly some amount of subjectivity. Wherever we involve community, environment, there will be subjectivity. There can't be complete objectivity in the approaches. But how much we can reduce that subjectivity through a analysis process, a pre-defined, pre-selected approach, and that's why these approaches are improving over time. It's not, there is not a one approach. And depending upon whether the planning is for a smaller time where we don't need to have too much analysis, because that also includes cost, going through the time of all the stakeholders, the analysis, the engineers, all those involved, they're putting their own, they're putting their time. So everything is cost, going to the cost. So basically the idea is how we can minimize the subjectivity for providing information to the managers, to those who are making the decisions. More information for them. That's all what we are going to do.
So nowadays, besides these economic, environmental, social, there are behavioral studies also, perceptions for the perceived community spaces, and particularly for the societies or the areas which are yet to be developed.
Yes. I think that aspect can be covered under the social, because social behavior that can cover that aspect. Talking to the community aspect is very important. and perception, because they whatsoever providing. Uh, we were looking in Adelaide uh, in few new developments which were designed based on integrated water management concept, and water sense urban design approaches were implemented. So we, in the group where I was working, I was leading a group with, and there were 2 or 3 social researchers. So they went to those developed areas, and there were towns or sorry, the groups of 50 to 100 homes, and they talked to the community about what they are, whether they are liking the system which has been provided, whether they are happy to pay extra, which is being the municipality charging with them, what benefit they feel. So, and then we talked to a group of maybe 20 or 30 in one go, bring all them together and listen to them, or sometimes talk to individual. So there are 2 type of social researchers. They either the group or individuals they talk, and then they analyze based on certain set of questions. So they develop a set of questionnaire, and sometimes it is open discussion too with the community, rather than starting questions 1, 2, 3, 4, 5, 6. They just put one question in the open forum and then ask them, the community, to put their views on any aspect of the development. And sorry?
Focus group discussion.
Focus group. Good. That's another name to that, yes. So in that way, we gather that information, and maybe that I will share a report about 6 or 7 developments which we investigated, the social research we conducted. Maybe that will give you some idea about what are the questions they ask these social researchers. And based on that, we provided information some to the state so that they can develop, they can take learnings from there in future developments. So this is how this cycle goes. You collect information, look what community is looking for, and use that information for the new development, because what is happening when we are approving the new development, the community is not there. Only the regulators will act as the supporters for the community.
My question from environmental effect. So this integrated urban water management related to in the scenario that water is taken from urban cities or something like that, arranging the recent urban cities are getting flooded from that aspect.
Getting flooded.
Most of the cities, due to the environment aspect, they are getting flooded, like Chennai or many cities. So we are designing that aspect, or from in the pattern of we are lacking water in the urban space from that aspect.
So we are considering all aspects. Integrated water management will also consider the flooding aspect. How we can reduce, minimize, mitigate the flooding aspect. It is not only providing water supply, it is also looking at the stormwater aspect. So where is flooding is happening, that means either the system is inadequate, that is one part. There can be the climate change impact and the other aspect. We are urbanizing the city without considering much about the flooding. So these are some of the factors which are contributing. So it is a question of overall planning. What is happening is in most of the cities, it is unplanned what is happening, without looking at the overall planning aspect of that city. And we are providing conditions to develop new areas without much thinking about what impact it's going to have in the other part of that city. How much impact it's going to have on the flooding aspect of. So either we look into the overall stormwater network to what extent They can take 150 years, 110, 120 years gains. The rainfall pattern is also changed. So the integrated water management covers that aspect too. Is that your question which I answered or slightly different now? You have information?
See, just to add to what you told just now, see, flooding in the Indian context, especially in urban areas, will only increase in the percent development direct conditions.
Yeah.
Because urban areas, as you rightly said, are being developed without any other considerations other than bringing up these high-rise buildings. See, earlier, I still remember 20 years back when I was attending one urban management, urban drainage course, a professor from Germany, he was saying that in many advanced countries, when major developments are taken up, just like we submit a plan for approval of a building, simultaneously you are supposed to give a document saying how you should change the local hydrology and what measures you take to offset that change. Whereas that we are not all doing, and even if we are required to submit a document like that, in Indian context, that will just remain on paper. So, this will only increase. If you take Chennai flood for Bangalore, Bangalore, for example, has been a city known for so many lakes. But most of the lakes have now been filtered. And especially these flats, apartment complexes from the CEOs of many companies had to escape the factories around lake beds.
So you're suggesting next order to regulation areas or they are being users dumping out?
Lakes totally disappeared.
Disappear.
In Chennai also, if you take the flood, many areas, for example, let's say there's a big drain, they want to reclaim that area, so they reclaim it and then put a small, just for saying that if they have maintained, they put a small cross-section pipe or something like that.
Yeah.
That aggravates the flood. This is what's happening. And to be very frank, the floodplains of rivers also are not properly defined. So it's all enclosed, people go and stay there and invite floods.
So I think I covered that aspect too, is that it is unplanned approval process on a piecemeal basis without looking forward. So when we are developing a new area, just providing a small pipe, a large pipe, and extending that to another pipe, which can be a little bit larger than that, whether that pipe has the capacity to carry the additional discharge or not, that is something, doesn't mean that those who are approving, they don't know. They are also aware of it, but there are so many other aspects which I can't discuss on this platform.
So I just cite another example. See, now everybody agrees that roads are required for development. But if you take major roads which are coming up, in many places, very high embankments are constructed. Now, these embankments, if you do not provide sufficient drainage passages for water to be taken from one to another, they serve as just earthen dams.
Yeah.
And if you take the 2018 floods, I know in area in our state, for example, areas which were not at all flooded before that event were also flooded. Partly because of this, it's not only this, but I'm citing one example.
Yeah, so I think there is an issue with the considering that aspect, that the water which may be collected on the other side of it, how that is going to flow across. There is some issues with the technical design, and I think these type of things should be highlighted so that the next time when somebody design, they take into consideration those aspects too. Yeah.
Sir, can you be grade?
Sorry?
E grade.
D. Yeah, should we have a break for? Okay, we can have.
Segment.
Yeah.
Can